Hi guys, welcome back. We're gonna keep going with chapter 4. So if you remember our last lesson, we were simplifying monomials, specifically by multiplying them. We were adding the exponents to simplify powers of powers or exponents with exponents. We were multiplying the exponents. So today we're going to look at dividing and what we do when we divide powers, and then also what happens if we have zero and negative exponents. So let's get started. Go ahead and flip in your notes to where we left off. And we're going to start with what we call quotient of powers, which is just when we're dividing monomials, okay, or dividing powers. So when we multiplied powers, you saw that we had to add the exponents. So it would make sense to say that when we divide powers, we just subtract the exponents. So here we have a to the m divided by a to the p. Because we're dividing, we just subtract the exponents to simplify it. So we get a to the m minus p. So if we try that here in the next example, we have c to the 11th divided by c to the 8th. When we divide, we subtract. So we do 11 minus 8, which gives us 3. So this will just become c to the third. And so we'll do that with r to the 5th divided by r squared. Since we're dividing, we just subtract the exponents, 5 minus 2, and we'll make that r to the 3, or third power. All right, so the next example, we've got x's and y's that we're dividing. So we're just going to do it one variable at a time. We'll start with the x's. If I have x to the 7th divided by x to the 6th, we just subtract the exponents. So 7 minus 6 gives us 1. So x to the 1, or just x. And then we subtract the exponents to divide the y's. So y to the 12th divided by y to the 3rd, 12 minus 3 gives us 9. So now we've simplified that to x, y to the 9th. All right, so next we have a to the 3rd, b to the 9th divided by ab squared. So we'll start with the a's. We'll subtract the exponents. So if this is a to the 3rd divided by a to the 1, 3 minus 1 is going to give us 2. So now we have a squared. And then we move on to the b's. B to the 9th divided by b squared. So 9 minus 2 is 7. So now we have a squared b to the 7th as our answer. Now we're going to look at what happens when we are dividing things inside parentheses, all being raised to a power. So just like when we were looking at power of a product where we were distributing the exponent to everything we were multiplying inside, it's going to work the same way with power of a quotient. We're just going to distribute the exponent to each term inside the parentheses. So if I have a divided by b all to the m power, we're just going to distribute the m so that it should be a to the m divided by b to the m. I mistyped that, so we'll fix that. So a to the m divided by b to the m. We just distribute the m to each term. Make sure you fix that in your notes too so you don't get confused. So if we look at 3/5 all to the 4th power, we can think of that as 3 to the 4th divided by 5 to the 4th. We can just distribute the exponent to each term inside the parentheses. Next, we have r over t all to the 5th power. So distribute the 5 to r and t. So r to the 5th over t to the 5th. And now we've simplified. Okay, so we're just distributing the exponent to everything inside the parentheses, just like we did when we were doing power of products last time. All right. So let's look at some more examples. These get a little bit more complex. Okay, so we'll start with this first example here, where we have the 3 that we need to distribute to everything inside the parentheses. So we'll start by doing 4 to the third power. Okay, distribute the 3. Let me turn my pen on. To the 4. And 4 to the third, if we type that in our calculator, will give us 64. Then we distribute to the c. So c to the third. Remember, when we have exponents with exponents, we multiply. So 3 times 3 gives us c to the 9th. And then we distribute to the d squared. And so 2 times 3 would give us 6. So that becomes d to the 6th power. And then all over, we end up with 5 to the third power, which will give us 125. Okay, and so now we've simplified. We've just distributed the exponent to everything inside the parentheses. So let's look at the second example. We're going to distribute the exponent to everything inside. So I'm going to do 3 to the third power, which is 27. And then m to the third, multiply the exponents. 3 times 3 gives us 9. And then n squared to the third becomes n to the 6th. 2 times 3, we just multiply the exponents. And then we go on to do the denominator. So 4 to the third gives us 64. And then p to the 5th to the third, we multiply the exponents. 5 times 3, and that gives us 15. And then distribute the 3 to the q. 1 times 3 is 3, so we're left with q to the third. And now we're done. Okay, so the next thing we're going to talk about is what happens when we have 0 as an exponent. We did look at this last year as well, so maybe you remember. Whenever we have anything to the 0 power, it always equals 1, okay? So for example, a to the 0 is 1. 5 to the 0 has to also be 1. And a divided by b all to the 0 has to be 1. Anything to the 0 power will always be 1. Okay, so this next one, sometimes people see a question like this and they start working through it and then they realize, oh, I don't really need to do any work because it's all to the 0 power. And since all of this is to the 0 power, we can just say the answer has to be 1. Now the next one is not all to the 0 power. We have m to the 0 power. So m to the 0 power becomes just 1. And then we have n to the third over n squared, right? We just made this m to the 0 a 1 because anything to the 0 power is 1. Then we can simplify. N cubed divided by n squared. We said when we divide, we just subtract the exponents. So we're going to do 3 minus 2, which is 1. So we're left with 1 n to the 1, which we can just write as n, right? If the coefficient is 1, we don't need to write it. And if the exponent is 1, we don't need to write it. So we're left with just n. So the last thing we're going to talk about for today's lesson are our negative exponents. And we did see these last year as well. So this is going to be a little bit more of review. When we have a negative exponent, the monomial is not fully simplified. To completely simplify the monomial, we have to get rid of negative exponents. So to get rid of a negative exponent, hopefully you remember last year, we just took the power and we flipped it. We did the reciprocal. Remember, reciprocal is just when we take a fraction, flip it over. And when we flip it over, when we do the reciprocal, the negative goes away. So for example, here we have a to the negative n. And if we want to think of that as a fraction, anything we can make a fraction by putting over 1. So what we do to make the negative go away is we flip that fraction. We move the denominator to the numerator and the numerator to the denominator. We just flipped it over, okay? Now, Once we flip it over, we eliminate the negative, and we're left with our answer, 1 over a to the n. So let's look at 2 to the negative fourth. To simplify 2 to the negative fourth, we just need to do the reciprocal, right? So we can think of anything as a fraction by putting it over 1, and then we just flip it. We move 1 to the numerator. We move the 2 to the fourth to the denominator. After we flip it, the negative goes away, and so we're done. Now this time you'll see our negative is actually in the denominator. To get rid of the negative, we have to flip it, move it to the numerator. So we flip it, and the j to the fourth goes on top, and the 1 goes on bottom. The negative goes away because we flipped it. And then anything over 1 is just itself. So we can think of that as just j to the fourth. Okay, 1 over j to the negative fourth simplifies to just j to the 4. All right, so let's look at a few more examples with the negative exponents. So the first one we see here, we have 2/5 all to the negative second power. Because the exponent is negative, to make the negative exponent go away, we just need to flip the fraction. So I'm going to flip the fraction 2/5 and do the reciprocal and make it 5/2. Once we flip it, that exponent becomes positive. Then we can do our power of a quotient where we just distribute the exponent to everything inside the parentheses and say that this is 5 squared over 2 squared. And if we want to evaluate that, 5 squared is 25 and 2 squared is 4. So 25/4 is what that ends up being. All right, now the next one, we've got x to the negative 4, y to the 9th, all over z to the negative 6. Now, when you've got multiple terms in a fraction and some are negative, rather than flip everything, we can just flip the variables that need to, okay? So I'm going to draw my fraction bar here, and I only want to move what's negative. All right, so if the exponent is negative, we do the reciprocal, which really just means we're going to move it to the other side of the fraction. So to make this x to the negative 4, x to the positive 4, we just move it to the denominator. So I'm going to write it down here in the denominator. And to move the z to the negative 6 to the numerator, to make it, oops, it's supposed to be a z. Let me get my eraser. To make it positive. So we have z to the 6th. Lucas, hop down, please. So then it becomes positive 6, and then since y to the 9 is already positive, we can leave that positive. All right, so let's do this one more time. We've got our fraction bar here. To make the negative exponent go away, anything that's negative, we just move to the other side of the fraction. So a to the negative 2 will go down to the denominator and become a to the positive 2. C to the negative 5 will come up to the numerator and become c to the positive 5. And b to the third is already positive, so we don't move it. We just leave it how it is, b to the third. And now we're done, okay? So you guys are going to practice this on IXL with whatever time is remaining in class today, and then you'll finish it for your remote assignment tomorrow. So if you need anything, you can email me. Otherwise, have a wonderful Thanksgiving break. And then hopefully I will see you when you come back. We'll talk to you later. Bye, guys.